If you've ever pulled warm, fluffy clothes out of a dryer and thought, wait, where did all that water go? Because a single load of laundry can start out holding a surprising amount of water, sometimes a liter or more trapped inside the fabric, and your dryer gets rid of it without damaging your clothes or turning your home into a steamy mess. So today, we're doing a deep dive, how your clothes dryer removes water efficiently, and why one small problem can make drying take twice as long. In the next few minutes, you'll learn the simple physics idea dryers use to pull water out of fabric, why tumbling matters as much as heat, the difference between vented and condenser dryers, and how to cut drying time without overheating your clothes. And if you're into these how everyday things actually work deep dives, subscribe, because I'm making more videos like this. Here's the whole dryer in one sentence. Motion, heat, and airflow. Those are the three ingredients. And whenever drying goes wrong, it's almost always because one of those three isn't working the way it should. Keep that in mind, because we'll come back to it. Dryers are basically water removal machines that happen to leave you with clean clothes at the end. And they're one of the bigger energy users in many homes. So understanding how they work can save time, reduce electricity use, and help your clothes last longer. It also explains why lint filters exist, because without proper airflow and lint control, a dryer can become a real fire risk. Let's start with the main problem: water trapped in fabric. Clothes aren't like a smooth surface where water just slides off. Fabric is made of tiny fibers woven together, which creates a huge network of microscopic gaps. Water clings inside those gaps using surface tension and capillary action, basically the same reason a paper towel absorbs a spill. So your dryer has one job: loosen the water's grip and carry that moisture away. Not burn it off, not cook it out, carry it away. Now back to our three ingredients: motion, heat, and airflow. First, motion. Tumbling. Tumbling constantly flips and separates clothes so they don't clump together. If clothes stay bunched up, the inside stays wet. That's why one thick item, like a hoodie, can keep part of the load damp. Tumbling also exposes new wet surfaces to the air, which helps drying happen faster. Second, heat. Heat gives water molecules more energy so they can leave the fabric and become water vapor. But heat alone isn't enough, because if that vapor stays inside the drum, the air becomes humid and evaporation slows down. Third, airflow. Airflow is the part people underestimate. The dryer pulls in relatively dry air, moves it through the spinning clothes, and pushes out moist air. And here's the key idea. Dryers work by constantly replacing humid air with drier air. Evaporation happens much faster when the surrounding air isn't already full of moisture. Here's a quick example. One time my dryer suddenly started taking much longer than normal. Same settings, similar loads. I assumed something was wrong with the dryer, but the real issue was airflow. The lint filter looked clean, but it had a thin layer of buildup that blocked air movement. After cleaning it properly, drying time went back to normal. So far, here's the simple idea. The dryer is motion, heat, and airflow. And in a moment, you'll see why even a small airflow problem, lint, vent issues, or overloading, can make drying take much longer. Also, if this is helpful, tap like. It tells YouTube this video is worth showing to more people, and it really helps the channel. Now, for the physics that makes it all click. Your clothes are constantly exchanging water molecules with the air around them. If the air is dry, it can absorb more moisture, so evaporation happens quickly. If the air is humid, it's already holding a lot of water vapor, so evaporation slows down. That's why clothes take longer to dry outside on a humid day. And it's why a dryer needs a way to remove moisture from the air inside the machine, either by sending humid air out or by pulling water out of the air inside the dryer. If a dryer can't remove humid air effectively, It's like trying to dry clothes in a room that already feels damp. Most classic dryers are vented dryers. They heat air, blow it through the spinning clothes, and then push that moist air out through a vent hose. So the water leaves your clothes as vapor and goes outside. Simple, effective, and usually fast. But there's a trade-off. Every time your dryer vents, it's also venting warm air. That's energy you paid for, leaving through the vent. So vented dryers can be quick, but they aren't always the most energy efficient. Now, let's talk about condenser dryers. Instead of sending moist air outside, they keep the air inside the machine and remove moisture by condensing it back into liquid water. A simple way to picture it is this. A vented dryer sends the moist air outside. A condenser dryer removes the water from the air and reuses that air again. Inside, moist air passes over a cooler surface called a heat exchanger. Water vapor turns into droplets, drips into a tank or drain, and the air gets reused. This is useful in places where it's hard to vent outside, like some apartments. Then there are heat pump dryers, which are one of the most energy-efficient options. They don't just remove moisture, they recycle heat more effectively using a system similar to what you'd find in an air conditioner or refrigerator. Instead of constantly creating new heat, they move heat around inside the machine. That's why heat pump dryers often use less electricity and can be gentler on clothes. The trade-off is they can cost more upfront, and in some cases, they may take a bit longer to finish a cycle. Now, here's the part that can make drying time jump. Airflow. If the lint filter is clogged, the dryer can't move enough air. Moist, humid air stays trapped inside the drum. That slows evaporation, so the dryer runs longer, uses more energy, and can overheat clothes. The same thing happens if the vent hose is crushed, blocked, too long, or has lint buildup inside. And even if the filter is only partly clogged, it can still reduce airflow enough to slow everything down. Because drying isn't just about heat, it's about removing humid air and replacing it with drier air. Quick myth busting. Myth 1, hotter always dries faster. Truth, it only helps if tumbling and airflow are good. If humid air is trapped, higher heat mostly just stresses the fabric. Myth 2, dryers remove water by cooking it out. Truth, the dryer's real job is moving moist air away from the clothes and replacing it with dry air. Heat helps start evaporation, airflow completes the process. Myth 3, more clothes is always more efficient. Truth, overloading reduces tumbling and airflow through the fabric, so drying becomes slower and less efficient. Here are the highest impact tips. Quickly. First, clean the lint filter every load. Second, don't overload the drum. Clothes need space to tumble. Third, shake out big items like hoodies and sheets before you start. Fourth, dryer balls can help bulky loads by improving separation and airflow. Fifth, use a stronger spin in the washing machine if you can. A faster final spin removes more water before the dryer even starts. That last one is a big deal, because removing water with spin is usually far more efficient than removing it with heat. So, where does the water go? Your dryer uses motion to expose wet fabric, heat to turn water into vapor, and, most importantly, airflow to carry that vapor away. Vented dryers send that moist air outside. Condenser and heat pump dryers remove the water from the air inside the machine and reuse heat more efficiently. And if your dryer suddenly starts taking forever, it's often not because the dryer is getting old. It's usually airflow, lint filter, vent issues, or a load that's packed too tightly. If you learned something new, subscribe for more how it actually works breakdowns, and leave a comment. What's the one item that always comes out still damp? Because there's a simple reason that happens, and it's probably not what you think.